Hello students, today we are going to discuss total differential. In total differential, we'll be discussing first order total differential and second order total differential. In our previous videos, we have already done partial differentiation. Let us do today total differential. Now what is total differential? Let me explain you with an example. The expression dz is equal to delta z by delta x into dx plus delta z by delta y into dy. This expression is often termed as total or complete differential. Right? Now, in the previous lecture we have done, suppose z was a function of two variables x and y. This was differentiated with respect to x once, that is delta z by delta y, and the second time this was differentiated with respect to delta z by delta y. Right? Okay? So this was a case of partial differentiation. But now in total differential, this is complete differentiation. So this is dz, the expression this is dz is equal to this one, delta z by delta x into dz plus delta z, this one, by delta y into dy. This expression is known as total differential. Now your question is, suppose you have a question given to you that z is a function of x and y, and this function is equal to 2x square y plus y cube. So according to this formula, we need to calculate delta z by delta x and delta z by delta y. Let us calculate this. Delta z by delta x. Delta z by delta x, this will be 4x y. We are differentiating with respect to x, so y will be constant. So this is 0. So answer is 4x y. Right? Now we differentiate this with respect to y, delta z by delta y. Right? So our answer will be, this will be 2x square, and this will be 3y square. Right? Now total differential, what will be the answer? First order total differential will be, total differential of z is dz is equal to delta z by delta x into dx plus delta z by delta y into dy. We have got the answer of delta z by delta x over here, 4xy into dx plus, this is the answer, 2x square plus 3y square into dy. This is our answer. Right? Clear? This is what we got is total differential of z. First order derivative, total differential. It means we have the concept of second order total differential as well. Second order total differential. Right? It means we have to differentiate it twice. Right? Let me first explain you the second order total differential. In the first order total differential, we got two results. One was delta z by delta x, right? And that was delta z by delta y. These are the two results of the partial differential. Now, again, if we differentiate it twice, right? This will be differentiated once with respect to x, and this will be differentiated with respect to y. So this we will get as delta square z by delta x square, and this will be delta square z by delta y into delta x. Right? We have two outputs from this one. Now we need to differentiate this in order to get the second order total differential. Right? This delta z by delta y, first it will be differentiated with respect to x, and second it will be differentiated with respect to y. So this will be delta square z by delta x into delta y, and over here it will be delta square z by delta y square. Right? Now you see that this expression delta by delta y differentiating delta z by delta x and this one, right, these both, whatever result we get from these both will be same. Expression is same, delta square z by delta y into delta x, delta square z by delta x into delta y. Right? This is what is concept of second order total differential. Let us move to the question of second order total differential. We have the question over here, that is z is a function of x and y, and that is equal to 7y log 1 plus x. This question has come in Delhi University BCom Honors 1992. Right? Now solution क्या होगा? First we calculate delta z by delta x and delta z by delta y. So over here y will be constant, over here x will be constant. I hope this concept is clear to you now. So this will be, do it uv, so this will be 7y log x, differentiation is 1 by x, that will be 1 plus x. Now again if you differentiate log 1 plus x, 7y, that will be constant, so this will be 0. So our answer will be 7y by 1 plus x. This is what the value is. Right? Now we have delta z by delta y. We consider x to be constant over here. Right? So which will be the result? This is equal to 7 log 1 plus x. Right? Fine. First we calculate the first order total differential, because the question says that you have to calculate the first and the second order total differential. So we apply this, dz is equal to delta z by delta x into dx plus delta z by delta y into dy. Whatever answer we have got, 7y by 1 plus x into dz plus, right, 7 log 1 plus x dy. This is the first order differential. Okay. Now we have to find we have to find the second order total differential. Okay, we calculate the second order total differential. So what do we have to calculate? It means this will be differentiated delta by delta x with respect to x ones, right? This is equal to delta square z by delta x square. This is also written in this way. Fine. We need to calculate this. So what is it? This is delta by delta x, and the result for this is 7y by 1 plus x. Fine. We need to find the second order total differential. This is in the form of u by v, right? You apply the formula u by v, that is equal to 1 plus x. You differentiate this 7y minus 7y 1 plus x by this square of the denominator. What you get? Again, when you are respecting with respect to x, y will be constant. So this will become 0 and this will be 7y, right? Minus 7y, okay, by, you are differentiating with respect to x. So 1 plus x square, right? This will be 1, this will be 0, fine. So the answer is minus 7y by 1 plus x square. Fine. Now we differentiate the same delta z by delta x, right? Delta z by delta x with respect to y. Once we did with respect to x, now we have to do with respect to y. So this will be delta with respect to y, delta z by delta x. This is also written as delta square z by delta y into delta x. Yeah. Differentiate it. Again, you apply the formula of u by v. What will you get? This is equal to 1 plus x 7y minus 7y 1 plus x by 1 plus x square. What will you get? You are differentiating with respect to y, so x will be constant. So this will be 7, 1 plus x, right? And then this will be 1 plus x square. This will be 0, right? This will be 0. This will also be 0. Multiply it, it becomes 0 ultimately. You cancel this, your answer will be 7 by 1 plus x, right? Fine. Now what you have to do, you have differentiated this, once with respect to x and then with respect to y. Now you need to differentiate this with respect to x and with respect to y, right? Okay. So we differentiate this with respect to y. Okay. So we differentiate this delta z by delta y with respect to y. So this will be delta square z by delta y square, right? What was delta z by delta y? It was 7 log 1 plus x. we are differentiating this with respect to y. So x will be constant over here. So the answer will be 0 when you differentiate it. Right? These are the initial steps. Now, what is the formula of second order derivative? Second order total differential. What will be the formula? It will be like, there in first order derivative we found what? Dz. So over here second order derivative, it means we have to find out d square z. D square z, d square z will be equal to, we had over there delta z by delta x, right? And we had dx in the first order. So over here it will be square, right? Okay, plus we had over there delta z by delta y, so we need square over here, delta y. And you saw that we have what? Delta square z by delta y into delta x 2 times, right, as explained you before. So this can also be written as over here in the formula plus 2 delta square z by delta y into delta x and dx into dy, right? So this is the total expression for second order total differential. You have to remember this. This is d square z is equal to delta square z by delta x square dx square plus delta square z by delta y square into dy whole square plus 2 delta square z by delta y into delta x into dx into dy. This is the total expression for second order total differential, right? So the question we were discussing, we have to find the second order total differential. We put this in formula, right? This is the formula, right? This we got. What did we get? Delta square z by delta x square. This is what we got as the answer. This was the answer. Look into your copy, right? So minus 7y by 1 plus x whole square into dx whole square plus delta square z by delta y square into dy whole square. What was the answer to this expression? It was 0 into dy square plus 2 twice of delta square z by delta y into delta x dx into dy. That came out to be 7 by 1 plus x into dx into dy. We simplify and write in this way. This is our answer, right?